Greetings and welcome to my SkyStudio on OpenTelemetry and traces. We're going to focus on OpenTelemetry, New Relic, Zipkin, and more. So what are some of the benefits of OpenTelemetry? OpenTelemetry is an open source observability framework. It provides a vendor agnostic way to collect telemetry data. That includes metrics, logs, and traces. By using OpenTelemetry, we don't have to bundle in third-party binaries, whether that's a Ruby gem or a NuGet package. We are using just a standard library that gets updated with our code. It avoids having to rebuild just because a vendor has an update. So if a vendor said, oh no, we need to update for our binary to collect data, you have to recompile your containers if you bundled it, and you don't have to do that if you're using a standard. And it lastly makes it a lot easier for local testing because we can just send it to like a local Zipkin if we're using Zipkin traces. This also gives us the ability to switch vendors. So if we were to get a better deal with another vendor, we always have that option. Some of the limitations of OpenTelemetry include it's not just as easy as adding a new Relic Ruby gem. We'll own that. And it does require developers to implement some traces in code. It's not that hard. It can be more complicated for serverless without a collector, though New Relic, our APM of choice, does have an OTel endpoint, so that makes it easier. So how does OpenTelemetry work? Well, we can use flags in code to turn on and off traces, though it's just as easy to throw away traces you're not using. And at the endpoint that you're sending traces to is most often an OpenTelemetry collector. So you can send them to Zipkin, which is usually 9411, or OTLP HTTP, which is 4318, or OTLP gRPC, which is 4317. But you send them out to a collector. What's nice about this is the license and vendor details are at the collector endpoint. So I don't need to pack in something like a New Relic API key into my containers, or even have my containerized services be able to know about a license key. They don't need to know about a Datadog API key or Sumo logic key. They simply know how to send trace data to a collector. Then that collector needs to know how to talk out to other endpoints. We can use frameworks like Dapr to auto-instrument and send traces to OpenTelemetry. We don't have to, but I am going to show an example of using Dapr because it makes it a little easier. Here's a quick example. I wanted to show a diagram that shows OpenTelemetry between two different endpoints so you kind of see how simple it is. The top half of this, as you'll see, is the same. So the application is generating traces, logs, and metrics and going to a collector. That collector here, this OpenTelemetry collector, then exports traces to traces that could be New Relic trace data or Cloud Trace. It can also send metrics out to New Relic, as well as logs. Same thing with GCP, going to cloud logging or cloud monitoring. In all cases, the changes come at the collector's exporter's level, not at the application level. And here you can kind of see the configuration. Really all that's different is the exporters here. We go to Google with a path to credentials, though we can also use federated identity. And the exporters go to an OTel endpoint. Now I do my headers block a little different, which I'll show you, but we can send the API key for New Relic right there in the exporter. I wanted to touch on logs. We're not necessarily going to get deep into logs because that's kind of a different topic, but here was an example where we were looking at using NXLog to send stuff to both Chronicle, our SIEM tool, as well as Google Cloud Logging. And it works, but there is a consequence of having to manage a third-party binary that we have to put on hosts and deliver it with BigFix. Another way that one could go about doing this is to use OpenTelemetry for logs. So here you can see we can easily use something like FluentBit and Logstash to send logs out from a Linux or Windows host, and then send it on to an OpenTelemetry collector, which can go to different backend. The backend is what receives and processes in batch the logs to exporters. Now, what might that look like? Let's get a little more real. So there's a Google Cloud exporter that we can use for the OpenTelemetry contrib, and that'll send metrics to the metrics endpoint for Google Cloud monitoring. It can send traces to Google Cloud Trace and logs to Google Cloud Logging. So we can send it to logging. From Google Cloud Logging, we can say a sync that goes to a bucket. And if you want to see what that looks like from code, here you can see that we have an exporter to Google Cloud right here, and we have the project right here. In this case, we assume that the containerized service that's running OpenTelemetry collector can see the project natively. This is a little bit of AI So I want to own that I didn't test this. I do another way to get my stuff out there. But here you can see the exporter for Google Cloud and a credentials file is set in an application environment variable. You'd have to test that. I will show another way I do that. And this is what the configuration looks like on Windows. I have used Fluent before on my Windows host to send it out to a now since defunct APM provider. So we can see that we can install with PowerShell, and then we can do a snippet. And in this case, you can see both cases. We have a localhost 8888. This would be the OpenTelemetry collector running in our network or in GCP that would receive it from our hosts and forward it on. Again, I don't want to get too deep into logging, but I did want to show you this is not hard stuff. This is stuff we could do if we wanted to do logging with OpenTelemetry. Here's an example of on-prem. So I kind of want to walk you through really doing some of these collectors. Now, in my case, I am using Grafana's Alloy, which is a new OpenTelemetry collector that just came out, and I find it pretty fun. It's not as feature-rich as OpenTel Contrib, but it is perfectly functional for things like ground cover or New Relic or some parts of GCP. In my cluster, you're going to notice that I have Prometheus set up for metrics. I have a couple of just random apps like Obsidian and Timesy. You can see my Dapr hosts that have been instrumented because they all have a Dapr sidecar that you see number 2s right here. So we have like add and subtract and calculator. And lastly, you can see the alloys right here. These are Grafana alloys. They're OpenTelemetry collector. So Zipkin doesn't have a logo, by the way, so I just invented one for funsies. So there's your Zipkin logo Isaac just invented. So the Zipkin pod that you noticed in this last screen, let's go back here one. You notice it was container creating stuck. That's because I used to use Zipkin to send all my trace data over to Stackdriver. And so I just want to point out this is a way that you can get stuff over to Google Cloud outside of the OpenTelemetry standard collector. And that's what I used to use. I turned it off because I'm cheap and I don't want to keep paying for it. But this is, you can see right there, I am using the Zipkin-GCP container that's designed to send stuff to GCP. So how might I go ahead and deal with that? So what I'm going to do here is I'm going to get my deployments, and then I'll see that I have that Zipkin that's stuck, the 0 out of 1 ready, is kind of the key that shows that it's a non-functioning deployment. I'm going to delete it. Next, I'm going to go ahead and create a deployment for Zipkin, just pointing to an image. Very bland. I didn't even tell what ports to expose. Next, I'm going to see that that deployment comes up. Don't worry, I fast forward a little bit here. Takes a minute on my cluster, but I'm using a lot of old off-the-shelf laptops to comprise an on-prem lightweight Kubernetes cluster. But there you see, 1 out of 1 ready, Zipkin's running. So now I can expose it as a service. So you'll see that I have a service already, but what I want to do is go ahead and delete it because I don't know if it's exactly right. That was what I used for Google Cloud. So I'll delete the Zipkin service. And then what I'm going to go ahead and do is expose my deployment. That will give the right selectors on the app, and use cluster IP because I'm going to keep it inside the cluster, and expose port 9411, which is both our UI as well as our collector endpoint for Zipkin traces. And you can see we got a new IP address. That was the other thing I was highlighting there, is the new cluster IP. Next, we're going to look at my configuration of Alloy. I'm not going to walk through a whole Helm deployment here, but this is the important parts. I have a config map, which you see referenced right here. And this is that config map right here. And you see I send it out to the OTel endpoint for New Relic, and I pass my header key in there. I'm not going to give you my header key because I don't want to pay extra. And you can also see on my Alloy that I am adding extra ports that this collector should be able to take in 4317 as well as 4318. So that's how it's going to ingest HTTP and gRPC respectively. So Dapr is my framework that I wrap around my calculator app, and it's going to automatically catch the pods talking to each other and send that trace data over to Alloy. So here you can see I'm using the standard kubedns of alloy.default, my default namespace, service, this Kubernetes service, cluster local 4318. And even though you see the protocol says HTTP, it's also a clue that 4318 is the HTTP default port for OTLP. So the idea here is my application with the Dapr sidecar is going to send trace data to the Alloy collector, which will receive OTel data, process it, and send it on to the New Relic OTLP endpoint. New Relic is going to receive it and create meaningful information, where we can also create things like alerts. So here's where you see it. This is my New Relic with my trace data, and here you can see it came from OpenTelemetry. Not only do you see the 4 right there, you can see it under Services OpenTelemetry. We can do things like look at our service data in APM, so I can see things like throughput and error rate. And we can see various metrics, trace counts and durations, errors, the P95, who called it and where it's going to. And I can look at individual trace data information here. All the things you'd expect to get out of traces. But what if we want to reduce costs? So I got this containerized app. You just saw it. You just saw it going into New Relic. What do I do next, right? So my next step is going to go ahead and change my Dapr configuration. So because my tracing, in my case for my application, happens at the Dapr level, I just need to get my Dapr configuration and change that OTLP tracing endpoint. And what I'm going to do is I'm just going to edit the configuration in line. So I want to say instead of OTel, we're going to use Zipkin format. And I could say protocol HTTP and then an address without it, but I'm just going to keep it simple. Do endpoint address with the protocol in there, HTTP://. Zipkin default service cluster local, and if you remember the port, it'll be 9411. And with the traces, because there's a web service, we got to do API v2 spans. And then we just remove out the other one. We don't really need standard out true, but that's nice for debugging if you want to see stuff. Can make things noisy. Now, when I edit the configuration, my pods don't rotate. You can see they're still running from 4 days ago. So what I'm going to need to do is go ahead and rotate all my pods. So I'll do a kubectl delete. They're all replica sets of all the pods. They're going to rotate pretty quick here. And in just a moment, we're going to see that they're all rotated and running. So my next step is to go ahead and port forward over to the calculator front end. Now, it doesn't matter what I'm doing here. I'm just doing some adds and some subtractions, some pluses and minuses and divides and times. Just doing some mathematical operations in here just to generate some trace data. I just want to generate some random trace data via my calculator front end. And this is having the microservices calling microservices to do their job. Almost there. Got a few more that I'm going to do. Then what I'm going to go ahead and do is port forward over to Zipkin. So in this case, I'm going to go to the Zipkin service. Later, I'll show you an example to going to the Zipkin pod. And I'm going to now go to browser where I will immediately forget that I port forwarded 19411 and realize it pretty quick that that's not the right local port, because sometimes I run a containerized Zipkin locally, so good to know that. And here's my Zipkin. I can now run query and see all my trace data. So these are the same traces that went to New Relic are now going over to Zipkin. If we want to see that, we can go over to New Relic and refresh and see that as of 30 minutes ago, I don't have any new data. And the front end is my most consumed resource. So it's another data point that it's not going to New Relic anymore. You can see things like the outputs, the trace data, the posts, the protocols, all the things you'd expect. And what's nice is because Dapr is sending these trace information out there, I can see how my services interact. So here you can see the calculator front end talks to a lot of stuff. The state store, which is a Redis on the back end, is where it's storing the calculations as it goes along. This also means we can do other things, like send it to ground cover, and ground cover by default collects eBPF packets. So I disabled it. That's why I have a green arrow there to show you that I am collecting an OpenTelemetry trace. And here you can see it in Datadog. I used to have kind of like a super Datadog account. I don't anymore. So this is a screenshot from earlier in the week. But these are the same traces going over to Datadog as well. Another thing to point out with OpenTelemetry, whether you're using Alloy or the standard collector, is you can go to multiple endpoints. So let's say I'm interested in another vendor. I'm going to make up a vendor. It's amazingapm.com, right? So now I want to go to amazingapm.com. I can send an exporter to amazingapm.com and New Relic at the same time to see what another vendor might look like. I could say I want to send to local Zipkin, but I then also want to send it to CloudTrace. All sorts of choices there. You can do two things or no things. There's where you have your exporters. In fact, this example here, you can see I'm doing traces and metrics, but there's no mention of logs. Logs are thrown out. They're not even used in this OTel. So it's kind of creating a sink going to dev null. So let's kind of summarize before we move on to the next section. So some of the benefits of OpenTelemetry is the loose correlation to vendor binaries. We can use standard protocols like OTLPs, HTTP, or gRPC endpoints, Zipkin, and Jaeger, configured with settings. There's the advantage of no bundling of third-party binaries. So that reduces the size of containers. We don't have to rebuild to address vendor upgrade issues. By not bundling, we are able to test locally. And we can do a mix of environments. We don't have to bake the conf into the container. It's easier for local testing. Again, I showed you a lot of Zipkin. The ability to switch vendors. So we could use things like GCP CloudTrace with OpenTelemetry. OTel is the industry standard. There's not like another one going on. This is what they're all backing. So any of the companies you're talking to, Dynatrace, New Relic, Datadog, Sumo, Instana, they all use OTel. So they're all going to have some sort of answer for OTel. And again, OTel can handle traces, metrics, and logs. I will point out it's always handled traces and metrics. Logs has really only come to a reality in this last year. A year ago, OTel logging was very basic and kind of beta. Some of the limitations, again, it's not as easy as just dropping a gem or a NuGet package. And it does get more complicated for serverless without a collector if you don't have a reachable OTLP endpoint. And with New Relic, we do. So you can stop here if you'd like. I'm going to go on to say, here is a demo, or as I like to write it, a quick unimpressive demo from somebody who once wrote a bit of JavaScript and think you won't notice all the AI fill-ins. All right, so we're going to do this in a fun couple of ways. So I'm going to start with IDX. So if you haven't used IDX, it's Google's hosted code server, which is a VS Code open source implementation already tied to Gemini for us. I do speed this up so you don't have to wait for it initializing the environment. It's free for now. I don't know if they'll ever charge for it. It seems like an awful nice gift to give for free. But that allows me to use VS Code tied to GitHub in a browser. I could do this on a Chromebook or an iPad if I wanted to. So here I'm up in the VS Code implementation in my browser. It's tied already to Gemini. You do have to rebuild your environment. It creates that .idx folder with some stuff. Later on, I don't show it in the window. In that packages block you saw there, I'm going to add Podman and Docker to have additional packages I want. So the first thing I was going to try was ask some questions of Gemini in the heading block. But what I've forgotten, and you may be realizing it while watching it, is that's really the shortcut window for Visual Studio Code, not for Gemini. So it's the wrong place to write a question. It was just, I didn't think of that. So I'm going to pop over Gemini over to the right-hand side, and I'm going to ask some questions such as, how might I add Zipkin tracing to an Express.js app? So it does look at my server.js here because it can have the context of my code. It's going to tell me what to add, and it's going to show me adding the traces and the context and implementing the Zipkin middleware. Now, I'm going to come back to this, but it's already wrong on the right. And I realize it now about how it was wanting me to insert traces already after using a middleware. It took me a while to figure that out later. So the thing about Gemini, and this is true whether we're talking about Copilot or ChatGPT, they'll give you really well-sounding bad answers. So they'll give you a good start. Most of that's right. But you still need to know what you're doing whenever you use AI, or you're going to get in trouble. So all those little span blocks there are wrong. They need to go away. That block is right. That's the middleware piece that starts the Zipkin tracing. And then lastly, what you'll notice is I did change it to take in a port because I want to be able to override that with my configuration. I don't want a hard-coded localhost because this is going to be running in various places. And this, by the way, is an Express.js app for uploading stuff to a PVC I wrote a while ago. It's a nice kind of simplified app I use for various demos. It's public, so feel free to take it and play with it. So my next step will be to kind of do an npm run to run locally. And then I realized that I don't really have a way to run locally. It's really meant to be within a Docker file. So what I do next is do some attempts at compiling with a Docker build. Now, in short, there is no baked-in Docker. It's going to want you to install it. And even when you're installing it like this, it doesn't take right away. And you end up having to mess around a bit with Podman to get it to live. So I'm going to skip ahead because what you do in this recording is I'm doing a lot of different attempts to get Docker to build. And eventually, I get it to compile with Podman by messing around a bit and changing that IDX setting. So it's doable. I clearly did it. But there is a bit of hackadoodle to make that happen. Once I have the local container image built, I can use a Podman invocation to get it to run. So what I'm going to try to do here is do a Podman run. I'll realize it's not Docker in a moment. And I did not set it to forward port 3000, which I sometimes now think might be my underlying problem why it didn't work in my local test here. What it did do, and this is why I wanted to run it locally, is it found I made a goof and I used a pound comment instead of a / in a JavaScript file. And I'm doing that. This is why I like to run it. You dance between languages. I do a heck of a lot of Bash and PowerShell. You inadvertently will always run into some sort of comment like that that takes you down. I clear out some of these spans. I'll forget the rest of them later. And then once it's built and I run it, I should be able to fetch the host and run it from there. So I should be able to either go to that on port 3000 or do 3000 dash and get it through there. But as you'll see, it's not really loading it. So I think maybe it's a port thing. It's just not able to connect to my backend. Maybe a setting I'm missing. It has worked for me in the past. But what we're going to do is we're going to move on. So what I'm going to do here instead is go ahead and commit this code and push it up to GitHub. What ends up happening is you need to, because remember I'm using an embedded code server in Google, I need to auth myself in with MFA and passkey to get through to GitHub and push my code. So we're all set up, and now now you can see I'm over in GitHub. So here in GitHub, it built and pushed. And you'll notice that I'm not only building and pushing my container image, I push my Helm repo. I'm a big fan of using OCI container registries for my charts. There's no sense in having a Helm repo anymore. Just put them where your containers are. They can live alongside. The other thing I'm kind of really getting into is using GitHub Attestation. You can use other attestations, but GitHub now offers one for free. And what an attestation is it kind of provides a certification. It's a stamp of authenticity on your container you could check against later on. So the way I can guarantee that this container and this chart really is the container and chart if anybody was to grab it or try to pass it off as something else. Some of the things I realized I need to update Helm. So what we're going to see here is my Helm repo, right? I did the container, but I didn't actually expose a way to set that Zipkin endpoint. I was like, oops, missed that one. So I'm going to go ahead in my values file and add in a Zipkin endpoint value that I can override. And I think I'll set it by default to localhost. There you can see Gemini jumping in for my help. And we'll find it over here. So Gemini was right with its suggestion. And now my deployment, I need to go ahead and actually use it. So I'm going to add in a block for the Zipkin endpoint that we were just using. And I just need to refer to the variable right there with the values. So I'll just copy paste from another spot and paste in what the actual one is, which is Zipkin endpoint. Again, better to use the clipboard than fat finger a change. Paste in my Zipkin endpoint, and now I have a working Helm chart. So it's just me checking everything one last time. So you'll see me commit and push. I don't need to auth again because I authed once already. And now I should see that it built. I did have some other changes I had to do later on, but it ends up building, and I have a working container, a working Helm chart. So some of the other things, when I look at my repo for my different builds, you can see the attestation that was created as well as for both the Helm chart, which is here, as well as the container image. So both get an attestation entry. And then I can do Helm pull and install for local images. So here you can say I did a git pull for OCI to GitHub CR. Obviously I'm authed to GitHub locally. Pull down my image. I open it up and I do a Helm install and I set it to the latest image. One of the things I realized is GitHub CR is not like Docker IO. It doesn't just give it to you for free. You have to be auth. So I'm going to need to create an image pull secret for this. So I create a GitHub token that I can use for that. And then I get some code to put in here. Now you can see it is telling me that I should use image pull secrets under a variable here for my code. Now I'm back into using Gemini in an actual fat client on my desktop. When I built and tested, I realized it is wrong. Again, a case where Gemini is very convinced about its answer, but you need to know what you're doing because the block for image pull secrets really belongs back out at the container level, not down under the containers. That was causing the Helm to not work. Once I get it to run, what we're going to see here is I want to use the Zipkin endpoint for my local server. So I'll do a Helm update. Now you can see I'm setting the Zipkin endpoint for my local Zipkin instance. And it's running. So let's kind of watch that in motion. So you see me get the pods. There's the Express uploader. I'm going to port forward to port 3000. I'm going to go ahead and choose some files to upload. I'll upload some 3D seed I had made. I'm going to go ahead and upload maybe an image or something. About a nice weather station image. There you go. And now I've done a couple of actions. That's really all I needed. That should generate some spans. So now let's go bring up Zipkin and see if we got any traces on our Express app. Oh, sorry, that's the next screen. I apologize. We're going to port forward. This time, I told you I'd do it both ways. I port forward into the Zipkin pod instead of the service. Same difference. Here we see Zipkin. If I run query, what we're going to find here, I'm getting the window lined up, what we're going to find here is my traces came in here. So we can see all the uploads, how long they took, all the details I expected to get from trace data are now collected and sent on to Zipkin. Now I can send this to New Relic just as well by pointing my OpenTelemetry collector over to New Relic. Now my trace data really only shows the interrelation of my calculator app because this service doesn't have another service to talk to. But it is handy to see that I can look at as much data as my Zipkin collector has collected in the time it's been alive. So pretty much it's infinite unless you kill the pod or kill its back end. The other thing you'll notice, I saw something had an error. So let's go ahead and look at that trace. What was the problem? I got an error not found. It was a 404. So I'm going to look more at that span and scroll down. And there you can see the problem. It's trying to get a fave icon. This one doesn't have a fave icon to serve. Not really an error I care about, but it was nice to see my Zipkin traces giving me a piece of actionable information. So thank you for attending and listening. OpenTelemetry is there. My repo is under ID Johnson Express Uploader. You can see the current code. I just did things on main, so it's all right there. And if you have any questions, you can let me know, but I appreciate the time.